In this video, we look at how to solve one- and two-step equations. In order to solve equations, really what we're trying to do is to isolate the variable, so get it all by itself on one side of the equation. And the way that we do this is by performing inverse operations. So inverse operations are like opposite operations. So the inverse of addition is subtraction, the inverse of multiplication is division. So let's have a look at an example here. Our first example says to solve x plus 9 equals 19. You can see here x is on the left. There's this plus 9 that's in the way. We want to get rid of that plus 9, so we need to do the inverse operation. I'm going to write this out. I know that you can do this question in your head without a whole lot of work. We're going to go through and do it systematically so that we can make sure we know how to do the harder ones. In order to get rid of that plus 9, we need to subtract the 9 on the left. And anytime we do anything to one side of the equation, if we want it to still be equal, we have to do the exact same thing on the other side. So we subtracted 9 on the left. We'd better subtract 9 on the right. 19 take away 9 is 10, so we get that x equals 10. Now we can check our answer by doing what we call a left side, right side check. I'll just move some of this down so we have a little more space. And in order to do that, what we do is we look at the left side of the equation and we look at the right side of the equation. We want to substitute this answer back into the equation and see if the left side and the right side are equal. So we have that x equals 10. The equation says x plus 9 equals 19. We know that we think that x is 10. 10 plus 9 is 19. The left side equals the right side. Hey, look at that. We were successfully able to solve that question. All right, let's have a look at the next one. So this one's a little harder to do by just kind of looking at it. The same sort of set of procedures would apply. We're trying to isolate x. There's x. We want to isolate it. X in this equation is having 2 added to it. So we have that 2 is being added to x, this 2 here. We want to get x isolated. To do that, we're going to do the inverse operation, which is subtracting 2. And again, if we do a subtraction of 2 on the left, we better do the same thing on the right. Positive 2 take away 2 is nothing, leaving us with x on the left. Negative 5 take away 2 is negative 7. Again, we could do a left side, right side check. I'll leave that for you to try. Next up, we have this negative 3x equals 15. So we're trying to solve this equation. You can see here, don't forget the understood operation in between here. Let's see if I can fix that up. The understood operation in here is multiplication. So with that negative 3x, that's understood to be negative 3 times x. And the way that we undo a multiplication is by division. We want to undo a multiplication by negative 3, so we'll divide by negative 3. If we divide by negative 3 on the left, divide by negative 3 on the right. Here, negative 3 divided by negative 3 is 1, leaving us with 1x, which we normally would just write as x. And then 15 divided by negative 3. Positive divided by a negative is a negative, and 15 divided by 3 is 5. And the last one-step equation that we're going to look at is this one right here. This is saying that some number divided by 4 equals 3. Again, I know that you probably know how to do this in your head, but let's have a look at it. X over 4, x divided by 4 is equal to 3. Here, x is being divided by 4. We want to undo that division by 4, and we do that with multiplication. And if we multiply by 4 on one side, we better do the same on the other side. Here again, 4 divided by 4 is just equal to 1, leaving x on the left, and 3 times 4 is 12. So we get an answer here of x equals 12. Pause the video now and get this note and these examples copied into your notes. So let's move on now to some two-step equations. They're called two-step equations because, well, they have two steps in them. You'll notice in the two examples here, we have the term with the x in it. There's another constant term, so there's a constant term here on the left and also another constant term on the right. Our goal is to collect all of the constant terms on one side, leaving the term with x in it on the other side, and that will get us to a one-step equation. So really what we're trying to do is to get this term with the x in it all by itself. In order to do that, we're going to get rid of the plus 6 that we can see here. And we do that, again, with the inverse operation. I'm going to start with the equation that we have, 2x plus 6. We want to undo an addition of 6. So the inverse operation there is minus 6. And we do the same thing on the right side. If we're going to subtract 6 on the left, we better do the same on the right. 6 minus 6 is nothing, leaving us with 2x on the left. 12 minus 6 is 6. And then from here, x is being multiplied by 2. Right here, 2 times x. Again, we don't see the multiplication symbol, but it's understood. To undo a multiplication by 2, we have to divide by 2. And if we divide by 2 on the left, we better do the same thing on the right. So we get an answer of x equals 3. Again, let's just do a quick left side, right side check here. So here's the left side, here's the right side. The right side's fairly easy. There's just 12 over here. And the left side was this, 2x plus 6. We think that the answer is 3, so we're going to take that 3 and substitute it into the equation here. So 2 times 3 plus 6 more. 2 times 3 is 6, plus another 6 works out to 12. If you need that intermediate step in there, by all means, include it, whatever helps you. So we get 6 here plus 6 here, and that's 12. So we get that the left side is equal to the right side. We've done this correctly. So you should be able to do a check on every one of your questions if you have enough time, just to make sure that you have done them correctly. All right, let's move on to this one here. Same kind of idea where we have the term with the x in it on the left, a constant term on the left, and then another constant term on the right. Our goal is to get the term with the x in it all by itself. Right now, we're adding 2 to that. We want to undo that addition of 2. So we do the inverse operation, which is subtracting 2. And if we subtract 2 on the left, let's do the same thing on the right. Well, what's left? X over 5 is still there. Positive 2 minus 2 is nothing. And on the right side, 6 minus 2 is equal to 4. Now we have that x is being divided by 5, so here's that division by 5. To undo a division by 5, we need to do the inverse operation, which is multiplying by 5. 5 divided by 5 is just 1, leaving us with x on the left side, and 4 times 5 works out to 20. So we found out that x is 20 in this case. And again, you can do a left side, right side check, or we can do kind of an informal check just by thinking about what happens when we substitute 20 in here. Well, 20 divided by 5 is 4, plus 2 more gives us 6. Looks like we did that one correctly. So pause the video, get these two examples in your notes, and then you can get started on the work for today.